Hey guys, welcome to my video continuing 4-4 factoring quadratic expressions. Today we're going to focus on factoring trinomials where my coefficient of my squared term is not equal to 1 and cannot be factored out using a GCF. So as always with a factoring lesson, we start by multiplying to see where we are coming from. So if I FOIL this out, 2x squared plus 2x plus 3x plus 1, plus 3, we see that we get the trinomial 2x squared plus 5x plus 3. All right. Now, again, if we are presented with 2x squared plus 5x plus 3 and are asked to factor it, we know that we have to get back to these two binomials multiplied together. So now, you may be able to see that right away by looking at the combinations of factors off the top of your head if you're a true math wizard. Okay, but for the majority of us, it could be helpful to get a process to help us factor. Okay, so the process we are going to be using is a process called grouping. And essentially what grouping allows us to do is what I call uncombined or like terms, right? To find the step in which that comes right before we combine our like terms so that we can essentially go back to our factored parentheses. Okay, so how would you factor this? Well, I'm going to show you. Using factor by grouping, and again, I focus on using this when a is not equal to 1. However, you could use it in theory when a is equal to 1. It's just a few extra steps that I don't think are necessary. Okay, so the first thing that you want to do is you want to find what we call the master product. Oops. Okay, the master product is found by multiplying my a value by my c. So in this case, multiplying my 2 times my 3. Now, when you do that, make sure you take the signs along with you because those are going to be of equal importance as they are in other factoring techniques. Okay, so now that we've found the master product, we're going to do something that it should be familiar to us. We're going to look at the factors of that master product, 1 and 6, and 2 and 3, and find the set that with signs add up to my b value. Okay, so in this case, 2 plus 3 adds to 5 and also multiplies to 6. So now what is going to change is what we do with those two factors. Okay, so instead of throwing them directly into our parentheses, we're going to do what I call uncombine our like terms. Okay, so I'm going to bring down the 2x and I'm going to bring down the 3. But what I'm also going to do is I'm going to split up my 5x using those two coefficients as 2x plus 3x, right? We know that 2x plus 3x is equal to 5x, so it's still equivalent. So we're just breaking it apart, okay? So those are the steps you have to do to prepare your quadratic to factor by grouping. The act of grouping comes in the next step, and it can be done anytime you have even number of terms. Okay, but I can group the 2x squared plus the 2x and the 3x plus the 3. And for each group, factor out a common factor, the greatest common factor essentially. So my greatest common factor for the first parentheses is 2x. I am left over with an x plus 1. Then I look at my second parentheses. I look for a common factor, which in this case is 3. And I'm left with an x plus 1. Okay? So now, here's where you can do a self-check. If, let's use a different color, this parenthesis, right, and this parenthesis are the same. Remember, common binomial, like we did in the last lesson. I like to call them twins. Okay? If those are exactly the same, I can factor them out as our common factor, our common binomial. And what is left over are the two coefficients that we have in front, the 2x plus the 3. All right, now if we look at that, that is the exact same answer that we got when we multiplied it out. Okay, so that is the process of factor by grouping. We find our master product. We look at its factors and find which factors add up to our middle term. We group, which is what this step is. We find our GCF. And then we factor out a common binomial. And that will work for any quadratic trinomial that you want to factor. And specifically, it will help make factoring when a is not equal to 1 a lot easier. So let's try another one. 4x squared minus 16x minus 9. So our first step is find the master product. So 4 times negative 9 gives me a minus 36. Okay, and I bring the minus with me. 4 times negative 9. I then look at the factors of 36. So 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. And I find which combination with signs will add up to a negative 16. So if I take a look at the factors and focus in on 2 and 18, right, I know that if 2 is positive and 18 is negative, they multiply to a negative 36, but also add to the minus 16. So I'm going to take those two, and remember, I'm going to make them the coefficients of x. So 2x minus 18x minus 9. Okay, so now that I have my 4 terms, I can go directly to my grouping stage. So I group these first two and I group these last two, but I want to make an emphasis here. When one of those middle terms is a negative, that negative must be absorbed into that parenthesis. So this negative 18 had to be all brought into the second bubble. Now, to make sure you remember that these are not our factor bubbles, but instead just our groups, I always write the little plus sign in between so you remember that we are adding these parentheses together and not multiplying. But the rest of the steps are the same. I'm going to factor out our common factor of 2x to get 2x plus 1. And I'm going to factor out our common factor here, which is 9, but we must also make sure that the parentheses are the same sign. So I can't have positives in my first parentheses and negatives in the second parentheses. So I must factor out a negative 9, leaving me with 2x plus 1 as our binomial. And now that we have taken the sign with us, all right, we have our twin step, which is our common binomial that we will factor out, and the 2x minus 9 as our second parentheses. And we are factored completely. Okay, so now for those of us who need steps, here we have it. The steps for factoring quadratics by grouping. All right, so the first step is to find the master product, a times c. Look at the factors of that master product that add up to b, our middle term. We do our third step, which is our uncombined like terms. This allows us to have an even number of terms in which we are able to group them by putting sets of parentheses around them. Then we factor out the GCF from each group. And then finally, we factor out that common binomial from each term. Okay. So there you have it. We have approached all of our factoring techniques from our factoring toolbox. On day 1, we talked about trinomial factoring and also perfect square trinomials. Okay, so those were the ones where we had x squared plus bx plus c, right? No coefficient for x squared. And we simply just looked for two numbers that multiplied to c and added to b. Okay, on day 2, we talked about difference of two perfect squares, right? That was when we had two terms, right? X squared minus y squared, each of which is a perfect square, right? Today we talked about grouping, which followed a similar structure from the trinomial factoring in that it was a trinomial, but we've made a focus when our a was equal to something other than 1. Okay, and then our greatest common factor, which essentially should be at the top of the list, made its way into all our different types of factorings because it's always the first thing you're going to look for. Okay, so now if you're struggling with when to focus on what methods, I have a flow chart for you to use to guide your factoring. So this factoring flow chart kind of gives you a place to start. And as you get better at factoring, right, you may not need this. Okay, but if you notice at the top is the very first question you should always be asking yourself, is there a GCF among the terms, right? Because that is always the first thing we're going to do. If yes, obviously you factor it out. If no, we continue, okay? Once you factor it out, you're still going to continue anyway to our second step. So now with quadratics, we have to then focus on how many terms do we have. Do we have 2 terms in which we should be looking for difference of 2 perfect squares? Or do we have 3 terms, which sets us up for either regular trinomial factoring or factor by grouping? Okay, so that's a decision you're going to have to make. Now, if it's a difference of 2 perfect squares, what do I always check? Well, I check, are my terms perfect squares? And is there a subtraction symbol in between? When I have my 3 terms, I always look at my ax squared term. Is the a equal to 1? Well, then I do regular basic factoring, right? And if it's a perfect square trinomial, I take it to the next step. If it is not equal to 1, then I focus on factor by grouping. So let's just apply this flowchart to a specific example so you can see what I mean, right? So the first question is there a GCF among the terms? Well, if we take a look at this example, we do have a GCF. We have a common 4 and a common x squared. So I'm going to factor that out, which will leave me with x squared plus 6x plus 8. Okay, now we go to our second parentheses. How many terms are there in the polynomial? And we see that there are 3. So then we have to make a decision. Is a equal to 1? So when we do this, remember, we are just focusing on the inside of our parentheses, right? Once the GCF is out, it literally just follows us through the question. So the question is this coefficient equal to 1? And yes, it is. So we're going to go down this road. So the question is, can it be factored into 2 binomials? AKA, can we find 2 numbers that multiply to the last term and add to the middle term? So looking at the factors of 8, we see that 2 plus 4 gives me 6 and also multiplies to 8. So we factor this parentheses into x plus 2 and x plus 4. And also bring along with us the 4x squared. Now that each parenthesis in its simplest form, we cannot do any more factoring. We can say that we have factored completely. Okay, so that's how you use your factoring flowchart, and we can apply this to any 3 or 2 termed expression. And that's where we will leave it. So here are the practice problems. Returning to page 221 and 222. Please attempt these problems with 87 being a challenge problem.